Welcome to the Open School, a school where teachers all around the world help students all around the world. So let's summarize. Work is a change of energy, i.e. the transfer of energy of one object to the other. Power, it's how fast it's done. Now, we talked last time about intensity. Intensity is the power per unit area. So it doesn't apply to mechanical forces, for example, although, kind of. But in our case, we're going to talk about light. Imagine you have some light. Got a big lamp here, flat lamp, that sends some light like this. And the power of the lamp is 100 watts, meaning that the lamp, so this is light, is giving as light 100 joules every second. Good. And now let's put a piece of paper that receives the light. So the piece of paper is, say, like this, about the same size as a lamp, and it receives 100 joules every second. But let's look at one unit of the surface of the paper. Say the paper is, I don't know, 2 meters like this and 3 meters like that. The area of the paper will be 2 meters multiplied by 3 meters, that is 6 meters squared. Now I can define a new quantity, the intensity. The intensity is defined by the power received per unit area. So that would be 100 watts divided by 6. So I didn't choose very good numbers. 100 divided by 6, so that's 16.7 watts. So each meter square, because there are 6 meter squares receiving 100 watts, each meter square will receive 16.7 watts. So we talk about watts per meter square. Yes? It's like if you divided the paper into 6 sections of each 1 meter square, and you can see it takes 1/6 of all the light. Yeah, normal, right? That's what intensity is. So let's illustrate this with an exercise. So let me choose it. Yeah, this one seems good. A flat lamp sends uniformly light energy on a surface of 20 meters square. The amount of energy received in 10 minutes, be careful, it's minutes, not seconds, 10 minutes, is 600 joules. What is the power received by the surface? And then, what is the intensity received by the surface? So, pause the video, try to do it by yourself first. Okay. In the exercise, we had this lamp that sent some light on a surface of 20 meters square. We say that the flat lamp sends some light energy on the surface, and the amount of energy received in 10 minutes is 6,000 joules. So, and we want to calculate the power. So the power will be equal to the energy per unit time. Now we know how much energy, 6,000 joules, were transferred in 10 minutes. So how many seconds in 1 minute? 60 seconds. So in 10 minutes, we have 600 seconds, 10 by 60. If I calculate this, I find 6,000 divided by 600, 10 watts. Now that's first question. But these 10 watts are going to be distributed on the surface, which makes 20 meters square. So each meter square is going to receive 1/20th of this power. We can write it mathematically. The intensity equals power divided by the area, which is 10 divided by 20 meters square. So each meter square receives 0.5 watts. That means each meter square receives 0.5 joules every second. This intensity thing, if you want to visualize it, you can see it like how bright it is. Yes, if you have received a lot of energy per second on a given area, well, it's going to be very bright. You'll have lots of light. On the other hand, if you don't receive much energy on this area, well, it's going to be very dull, right? So the intensity will be small. It won't be bright at all. Okay, so let's do another exercise of this kind.